Hello everyone, welcome back to the DSA for Beginner series. In today's video, we are going to learn one of the most important problem solving patterns in data structures and algorithms, the two-pointer technique. So this pattern appears in coding round at most companies like Amazon, Microsoft, Google, Flipkart and many others. Once you understand two pointers, you'll be able to solve many arrays and string problems efficiently. Let's get started. So what is two-pointer technique? So two-pointer technique uses two indices or pointers to traverse a data structure. Instead of using a nested loops, we use two pointers to reduce complexity. Many problems take O of n square that can be optimized to O of n using two pointers. So when should you think of two pointers? Whenever you see a sorted arrays, pair of elements, triplets, removing duplicates, reversing arrays, palindrome checking, LinkedIn problems. So if you see any one of these patterns, two pointers should be immediately your first priority. So let's take a simple example of how two pointer arrays work. So let's take an array of 1, 2, 3, 4, and 5. So if the problem statement is to reverse this particular array in O of n time complexity, what usually brute force do is run two pointers. Okay, so this is the array. So how if the problem statement is to arrive at this particular solution, what we do is, so we'll start a pointer from starting, which is 0, and 1 from n minus 1 position, which is 4. So we'll swap these two, we'll swap these two. So end of the, once we swap, right, so I will move here and j will move here. So which is I plus plus and j minus minus. I hope this is clear. So what is the time complexity of this particular approach if we take this? So since we are iterating all the elements only once, so the time complexity of the algorithms will become O of n. And space, we are not adding one any more entries, or we are not creating any new memory. So it is O of 1 for space complexity. So it is O of 1. Similar way, let's take another example where we are going to check if a string is a palindrome or not. Similar concept as this. So let's start a pointer from starting and the ending of the position. We'll compare is first and last are same. Then if it is this, then we'll add once I to the next and j one previous. So again we'll check if a equal to and the loop ends at the middle point. So that's how we see it is a palindrome or not. So next problem statement is to sum in a sorted array. So let's say I have 1, 2, 3, 4, 6. So I need to find my target as 6. So what we usually do is we will use two loops, one for I equal to 0, I less than a dot length So here we'll check I and j if the target is this. So the same goes through all the elements. That will, So yeah, if we go via this brute force approach, right? So we have two loops. So the time complexity will become O of n square. So how are we going to uh, optimize the approach for finding a target? So let's suppose what was the array? 1, 2, 3, 4, and 6. Target is 6. So we'll start I from again same 0 and n minus 1 position. So j here. So we will check if we will check I and j, we'll check the sum of I and j. Okay, yeah. So the two pointer approach for this problem is we'll check the sum of I and j position. So a of I plus a of j equal to how much? 1 plus 6, which is 7. And this is not equal to target, which is greater than what we expected. So what we need to do is, since the array is already sorted, we know that end at the end of the array, the items will be large. So what we need to do, we need to reduce the jth index. So what will happen? So j will come one position lesser, which is at 3. So again, we'll check 1 plus 4, which is 5. Now we'll check if the target, the sum which we got is equal to target, which is not equal. And we'll check if the sum is lesser than or greater than target. Here it is lesser. So what we have to do is we have to advance I to one position more. So I will go to first index. Now we will check the sum. Now 2 plus 4, which is equal to 6, that is equal to target. So by this approach, we will find ith and jth index. So what we saw in this particular approach is, since the array is sorted, if the sum is too small, move the left pointer because larger values exist on the right. If the sum is too large, move the right pointer because the smaller values exist on the left. This eliminates many unnecessary comparisons. So let's go to another example. So let's say we have one. So the problem statement is we need to move all the duplicate element to the end. So what it should happen? 2, 3, 1, 2. So as we saw in your previous examples, we cannot have I and j here because we don't know, like we cannot swap the first and last element here because duplicates can be any number and it can be at any place. So what can we do now? What can be done? So we have another concept called slow pointer and fast pointer in the two-pointer approach. So slow pointer and fast pointer. So for example here, so let's take I and j at the same place. So what happens is slow pointer will traverse one position at a time and fast pointer can travel more than one. One, two, or one, two, three, depending upon our logic. So in this particular problem, what we can do is, so I will be at the 0th position. So j will go until it doesn't match the element at the ith index. So for example, j will traverse until num of I not equal to num of j. So here first j will be incremented one time. So here num of I and num of j are equal. So again it will so the moment num of I is not equal to num of j, I is incremented and the element which is present in jth position will be copied here. So what will happen? The array will become 2 and then 2, 2 and 3. So what happens in the next iteration? So again, so it will go, so j will be here, I is here. So j will traverse until, since, okay, let's take it here, I comma j. J will traverse until num of I not equal to num of j. So what will happen? J will go to next element. Again it is same, next element. Since this both are not same, I will be incremented to one place and then the value which is present in the jth position will be copied here. So what will happen? 1, 2, 3, 2, 3. So here you are. Okay, so in this particular session, what all we saw? 2 pointer patterns. One with the opposite directions, which helps in finding out patterns like palindrome, reverse an array to some sorted array. And another approach where the 2 pointers traverse in the same direction. One is fast and one is slow. Example, removing duplicates, move the zeros to the end, linked list problems. So a simple hack, whenever we are trying to have two for loops, for example, for int I equal to 0, I less than n dot len, I plus plus, for j equal to 0, j less than n dot length, j plus plus. So whenever you think of having this particular pattern, then we can think of, can we solve this particular problem with a two-pointer approach? Many interviews optimizations come from replacing nested loops with pointer movement. Okay, so what all we learned today? We saw how it can reduce the complexity from of n square to n in by including two-pointer approach. So in our next video, we'll see stack, queue, and other data structures. If you enjoyed this video, don't forget to like, share, and subscribe. See you next time. Happy coding.